Welcome to the Genius Factory. Enjoy the video.
Start by defining the problem clearly and choosing supervised learning for prediction tasks. Collect a labeled dataset with at least 1,000 rows or more when possible. Split data into an 80/20 train versus test split and save validation. Clean data by handling missing values, encoding categories, and normalizing numerical features. Choose simple models first, like linear regression or a small neural network with 2 layers. Document assumptions, versions, and a reproducible pipeline using scripts and notebooks for clarity. Prepare a simple baseline model to compare future improvements and set expectations. Engineer features that capture signal, such as date parts, ratios, and aggregated statistics per user. Impute missing values using median for skewed numbers and mean for symmetric distributions. Scale features with standardization or min-max scaling depending on algorithm sensitivity to magnitude. Select evaluation metrics like accuracy, F1, AUK, or RMSE aligned to business goals. Set training hyperparameters. Batch size 32. Learning rate 0, 1, and 50 epochs as a baseline. Use cross-validation or a holdout validation set to tune hyperparameters reliably and avoid overfitting. Document experiments and log hyperparameters for train the model on the training set and monitor training and validation losses each epoch. If validation loss increases, apply regularization, dropout, or reduce model complexity to generalize better. Evaluate final performance on the test set and report chosen metrics with confidence intervals. Package the model, include preprocessing steps, and version the artifact for reproducible deployment. Deploy using a REST API or batch job depending on latency and throughput requirements. Monitor predictions, track data drift, and retrain regularly when performance drops beyond set thresholds. Set alerting rules and automate rollback when models degrade against the baseline.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.